Alright, let's go. Okay, pointer arithmetic. Pointers that address array elements can use all the iterator operations listed in table 6 and okay 3.7. These operations dereference, increment, comparison, addition of an integral value, subtraction of two pointers have the same meaning when applied to pointers that point an element in a built-in array as they do when applied to iterators. Okay. When we add or subtract an integral value from to or from an pointer, the result is a new pointer. The new pointer points to the element the given number ahead or behind of the original pointer. Okay, so we have this find size 5, then pointer is this, then pointer points to the last element. Okay. Okay. The result of adding 4 to IP is a pointer that points to the element 4 elements further on in the array from the one to which IP currently points. The result of adding an integral value to a pointer must be a pointer to an element in the same array or a pointer just past the end of the array. Okay, arrays ARR is converted to a pointer to its first element. P1 past P1 past element of array. Okay, so pointer P error. Array has only 5 elements. P2 has undefined value. Okay. When we add size to array, the compiler converts array to a pointer to the first element in array. When we add size to the pointer, we get a pointer that points to SZ positions. Z positions, that is 5 positions from the first one. That is, it points one past the element in the array. Okay. And then we have computing a pointer more than one past the last element is an error, although the compiler is unlikely to detect such errors. Right. Okay, as with iterators, subtracting two pointers gives us the distance between those pointers. The pointer must point to an element in the same array, okay, which is the size of the array. The result of subtracting two pointers is a library type named like size t. ptrdiff t is a machine specific type and is defined in the cstdf header. Because subtraction might yield a negative distance, ptrdiff t is a signed integral type. Okay. So we can use the relational operators to compare pointers that point to element of an array, right? If b is less than end, obviously, or one past the last element. For example, we can traverse the entire array like this. Okay. We cannot use the relation operators in pointers of two unrelated objects. Okay, undefined. Okay. Yes, size. Although the utility may be obscure at this point, it is worth noting that pointer arithmetic is also valid for null pointers and for pointers that point to an object that is not an array. In the latter case, the pointers must point to the same object or one past that object. Okay, if p is a null pointer, we can add or subtract an integral constant whose value is 0 to p. Okay, if p is a null pointer, okay, we can subtract two null pointers from another, in which case the result is 0. Okay, interaction between dereference and pointer arithmetic. Okay. The result of adding an integral value to a pointer is itself a pointer. Assuming the resulting pointer points to an element, we can dereference the resulting pointer. Right. We go IA last and initializes. Okay. Int last is 8. The expression dereference bracket IA plus 4 calculates the address of 4 elements past IA and dereference the resulting pointer. This expression is equivalent to IA of 4. Okay. Recall we noted that parentheses are required in expressions that contain dereference and dot operators. Similarly, the parentheses around the pointer are essential in writing. Okay, so last equals, we dereference IA first, then we add 4. Okay, last equals 4, equivalent to IA of 0 plus 4. Means dereference IA and add Hold up. Okay, writing this. Okay, last means dereference IA and then add to reference value. We'll cover the reasons for this behavior here. Okay, subscripts and pointers. As we've seen in most places, as we've seen in most places, when we use the name of an array, we are really using a pointer to the first element in the array. One place given where compiler does this transformation is when we subscript and array. Given Okay, when we subscript an array, if we write I of 0, that is an expression that uses the name of an array. When we subscript an array, we are really subscripting a pointer to a element in that array. Okay. So IA2 this points to the first element, and this points to IA2. Okay. We can use subscript operator on any pointer. Okay, we can use subscript operator on any pointer as long as the pointer points to an element or one past element in an array. Okay. So it's the same as okay. We're going -2. Oh, okay. So P of 1. So we are taking the reference to the second element, then P1 is equivalent to star of P plus 1. P1 is the same element as P of 1 is the same element as I of 3. Right. This is important. Okay. This last example points out an important difference between arrays and library types such as vectors and strings that have subscript operators. The library types force the index used with the subscript to be an unsigned value. Okay. The built-in subscript operator does not. The index used with the built-in subscript operator can be a negative value. Of course, the resulting address must point to an element in or one past the end of the array to which the original pointer points. Okay. Unlike subscripts for vectors and string, index of the built-in subscript operator is not an unsigned type. Okay, so this is exercise 3.5.3. Okay. Exercise 3.5.3. We'll see. Okay. Given the P1 and P2 point to an element in the same array, what does the following code do? Are there values of P1 or P2 that make this code illegal? Okay. So what it basically does is it goes P1 equals P1 plus P2 minus P. Okay. So if you basically say this is equivalent to being okay, so P2 minus P1 will be an integral value, right? And we add that integral value to P1. Okay, so this is equivalent to well P1 minus P1, or basically okay, so it says plus equals okay. So if I open the expression, right, so it is basically P1 equals P2. Given P1 and P2 points to an element in the same array, what does the following code do, and are there values of P1 and P2 that makes this code illegal? Huh. What? So this is P1 minus P1, so we are basically saying P1 equals P2. So P2. Okay, so see, P2 minus P1 will be some value, and this is P1 plus that value. So we are incrementing or decrementing. Okay, if P1 is end of the end pointer and P2 is the beginning pointer, okay, let me try this. Uh, 3.34. Yeah. Okay, let's create an array. So 1, 2, 3, 4, 6, and let's go with P1 equals array star P2 equals address of array of 6. Okay, let me see if this is valid. Right, okay. Yeah, okay, alright, cool. Okay. Then I write the expression P1 plus equals okay, let me just point to the last element. Okay. Plus equals P2 minus P1. Then I want to see what is the value that P1 points to, right? Okay, so it basically turns, right? So it basically assigns the value at which P2, which I thought equivalent to P1 equals P2. Basically that, right? If okay, given P2 points to elements in the same array, what does the following code do? Are there values of P1, P2 that makes this code illegal? Okay, so let me switch it up, and then we will see what will this code do. Okay, so if I have okay, P2 is the first element, and P1 P1 equals P2. Are there values of P1 and P2 that makes this code illegal? What could be the values of P1 and P2 points to elements in the same array? What does the following code do? P1 2. Are there values of P1 and or P2 that makes this code illegal? Okay, basically if we are saying that these are equal, right? Let me think. if I have p1 is of the end pointer, okay, but it has to be 0.2 elements. Okay, so if p1 is of the point, right, so end plus beginning minus end, okay, so have and p2 points to, let me see, okay, p1, if p1 is of the end pointer, right, then p1, then this is, if this is the beginning, so we'll point to the beginning, and if this is also p2, if p2 is also of the end, then this would be 0, because both are 0 and p1 equals p1. Or I don't think there will be any values. That should be illegal here, right? Okay, maybe let me try. Let's ask this guy. Where is? There we go. Okay. And C++ is referring to the situation ptr def p2. No. Both point to the elements in the same area, one pass to otherwise behavior. Oh yeah, okay. Yeah. Okay. Right. Okay. Are there values of? Yes, illegal. Yes, if p1 and p2 points to elements outside of the same side of the same array. Right, I just learned about that. Okay, using pointers, write a program to set the elements in an array to 0. Okay, that is easy. I can do that. 135.cpp. Points to the first element in the array. Using pointers, write a program to set the elements in an array 0. Okay, I can get okay, so I should use beginning and end pointers, right? Begin, here are, and these were defined in iterator. Okay, then we go while b is less than e, right? I can go value at b equals 0, and then I increment b right. Okay, so using pointer array program to set the elements in an array to 0. Okay, so let me define 1 2 3 4 5. Let's print let's print the elements auto b equals begin array, and while b is not equals to end of array for b plus plus, I want to see out value b. Oh, and oh, sorry, my bad. Okay, we have all zeros, so that is done. Then write a program to compare two arrays for equality. Program to array. Write a program to compare two arrays for equality, and write a similar program to compare two vectors. Okay. So this all 336.cpp hash include stream, include iterator. Then I have using std out, begin std end. Okay. Okay, so let me write two arrays, and array 1 of okay, array 1, oh sorry, int array 1 of size 5 equals 1 2 3 4 5, and array 2 of size equals 2 3 4 5. Okay, let's start a loop. Into p1 equals begin error 1, and auto b2 equals begin of, maybe I should define these outside, right? Auto b1 equals begin error 1, these are pointers. Auto b2 equals begin error 2, right? Then I should also define the ends. Then I have auto e2 equals end of error 2. Okay, so now check equality. Right, so I'll first check. So for we are missing that. So I want to check that e2 minus b2 should be equals to e1 minus b1, and along with that I want to check that p1 should not be equals to e1, and p2 should not be equals to Okay, check for, we are only checking for equality, right? Compare to arrays for equality. Okay. So we have p2 equals to e2, then we go p1 plus plus and plus plus p2. Okay, so we make sure that the the sizes are equal. Okay, maybe I should put this here. Also, we just print out arrays are not equal, and then okay, compare the values. So I have value of if not value of p1 equals value of p2, then we say out arrays are not equal, and if all of this is and if all of this works fine, right, and if all of this works fine, then we go, but shouldn't I use point? Oh, doesn't matter, this code is valid. Okay, if everything goes right, then we print okay, if it equals okay, right, if everything goes right, we print arrays are equal. Let me compile this. Okay, p1 used but not defined, so auto p1 even minus p1. Okay, label p1 used error 19 plus p1. Oh, sorry, forgot this. Arrays are equal. Okay, and if I say if I have 4 that are not equal and 4 6 with the size 5. Okay, so I have no implication on size. Arrays are not equal, arrays are equal. Ooh, right, okay. So if we say okay, so compare the values. If not, arrays are not equal if everything goes right. Right. I also need a boolean, a bool equals true. So we'll go true equals true equals false, equals false, and then I can simply check if equal, then arrays are equal, then arrays are equal, else yeah, arrays are not equal. Yeah. Okay. Then you want a similar program for vectors. Comparing vectors. Okay, so we go vector of int v1. Okay, yeah, it takes a list initialization. Go 1, 2, 3, 4, 5. Let me go v2 if v1 equals v2. Then we go vectors are equal, else we go vectors are not equal. Vectors are equal. Okay, then let's say go 4. Vectors are not equal, and 6. Vectors are not equal. Right. Okay. We can check, right? We make sure the sizes are equal. If it is not, then it is already not equal. Then we compare the values. Equals to b2. We'll run the loop. Then we move on to C style strings, character strings. Although C++ supports C-style strings, they should not be used by C++ programs. C-style strings are a surprisingly rich source of bugs and are a root cause of many security problems. They're also harder to use. Character string literals are an instance of a more general construct that C++ inherits from C-style strings. C-style strings are not a type. Instead, they are a convention for how to represent and use character strings. Okay. Strings that follow the convention are stored in a character array and are null terminated. By null terminated, we mean that the character in the string is followed by a null character. Ordinarily, we use pointers to manipulate these strings. Okay. C library string functions. The standard C library provides a set of functions listed in table 3.8 that operate upon C style strings. These functions are defined in C string header, which is C++ versions of. Okay. The function in table do not verify their string parameters. Okay. The pointers passed to these routines must point to null terminated arrays. In this case, CA is an array of disaster season. Okay, yeah. Okay, this is important. Okay. In this case, CA is an array of char but is not null terminated. The result is undefined. The most likely effect of this character is that strlen will keep looking through the memory that follows CA until it encounters the null character. Okay. Str compares copies. Okay. So comparing two C-style strings is done quite differently from how we compare library strings. When we compare two library strings, we use the normal relational or equality operator, right? Using these operations on similarly defined C-style strings, compare the pointer values, not the strings themselves. Okay. Remember that when we use an array, we are really using a pointer to the first element in the array. Hence, this condition actually compares two const star pointers. Those pointers do not address the same object, so the comparison is undefined. Right. To compare the strings, rather than the pointer values, we can call strcmp. That function returns 0 if the strings are equal, or positive or negative, it's depending on whether the first string is larger or than the second. Okay. So we have caller is responsible for the size of a destination string. Concatenating or copying C-style string is also very different from the same operations on library strings. For example, if we wanted to concatenate two strings s1 and n2 defined above, we can do like this. We initialize largest str as a concatenation of s1 space s2. Doing the same with the two arrays c1 and n2 would be an error. The expression cal1 plus s tries to add two pointers, which is illegal and meaningless. Okay. Instead, we can use strcat and strcopy. However, to use this function, we must pass an array to hold the resulting string. The array we passed must be large enough to hold the generated string, including the null character at the end. The code we show here, although a common usage, is fraught with potential for serious error. Okay. So disastrous if we miscalculated the size of copies cal into this, concatenates with plus and then concatenates this. Okay. The problem is that we can easily miscalculate the size needed for the large str. Moreover, anytime we can change the values we want to store in large str, we have to remember to double check that we calculated its size correctly. Unfortunately, programs similar to this code are widely distributed. Programs with such code are error prone and often lead to serious security checks. Right. For most applications, in addition to being safer, it is also more efficient to use library strings than C-style strings. Okay. Then we have, what does the following program do? Send and okay, so you get the value. Okay, as expected, it would keep on going until it encounters a null character in memory, right? Okay. In this section, we noted that it was not only illegal but meaningless to try to add two pointers. Why would adding two pointers be meaningless? Okay. As they are pointing to two different memory regions and would not point to and would easily point past the uh, memory on the outside of the program. Okay, write a program to compare two strings. Now write a program to compare the values of two C-style strings. Okay, we can do that. Write a program to define two character arrays initialized from string literals. Okay. Now define a third character array to hold the concatenation of two arrays. Use str copy and str cat to two arrays in the third array. Okay. It's been 40 minutes. Hold up. Okay, then let's write this function. This is exercise 3.5.4. I think I have, yeah, 5.4. Cannot find 3.5. Oh, sorry. It's exercise. Exercise 3.5.4. Okay, let's question 1. What do you mean question 1? Okay, let me just move question 1 to, I think it's 3.37. Question 2, question 3. 3 points. Oh, let me take a look at this. Okay. Alright, so basically what I've done here is that. So what is in question 2? Comparing. Okay, so I'm comparing strings. Compare. Right, okay, so I've already done this, comparing C-style strings. 1, 2, str compare, greater than 1 is greater, right. If it is greater than 0, then 1 is greater, if else 2 is greater. Okay, so I have this, so it's basically 3.39. Okay, so I will move question 1 to 3.37.cpp, and let's get this. Question 2 to 3.39.cpp. Okay, and then finally I have question, I suppose that is 3.40. So move 3.40.cpp. Okay, 30. Yeah, okay. So write a program to define two character arrays initialized from string literals. Now define a third character array to hold the concatenation of the two arrays using str, cpy and strcat to copy. Okay. So first I copy 1 and 3, then I scat 3 and 2. Concatenate 3 2 into 2. There we go. Okay, interface. I hope. So this is right. Okay. 8. Oh, sorry, there is not 3 8 now. 39. Okay, comparing. So right. Okay, yeah, great. Then we have interfacing to older code. Many C++ programs predate the standard library and do not use the string and vector types. Moreover, many C++ programs interface to programs written in C or other languages that cannot use the C++ library. Hence, programs written in modern C++ may have to interface to code that uses arrays of C-style character strings. The C++ offers facilities to make the interface easier to manage. Okay, mixing library strings and C-style character strings. We saw that we can initialize a string from a string literal, right? Okay. More generally, we can use a null terminated character array anywhere that we can use a string literal. All right. Okay. We can use a null terminated character array to initialize or assign a string. Okay. We can use a null terminated array as an operand, but not both operands to the string addition operator. Okay. The reverse functionality is not provided. There is no direct way to use a library string when a C-style string is required. For example, there is no way to initialize a character pointer from a string. There is, however, a string member function named CSTR that we can often use to accomplish what we want. Okay. CSTR. Okay. The CSTR indicates that the function returns a C-style character string. That is, it returns a pointer to the beginning of a null terminated character array that holds the same data as the characters in the string. Okay. The type of pointer is const char, which prevents us from changing the contents of the array. Okay. The array returned by CSTR is not guaranteed to be valid indefinitely. Any subsequent use of s that might change the value of s can invalidate this array. Okay. So it's not guaranteed to be valid indefinitely. Any subsequent use of s that might change the value of s can invalidate this array. If a program needs containing access to the contents of the array returned by str, the program must copy arrays returned by CSTR using an array to initialize a vector. Okay, we noted that we cannot initialize a built-in array from another array, nor we can initialize an array from a vector. Okay. However, we can use an array to initialize a vector. To do so, we specify the address of the first element and one past the last element that we wish to copy. Okay, so there we go. The two pointers used to construct IVEC mark the range of the values to use to initialize the elements in IVEC. The second pointer points to one past the last element to be copied. Okay. In this case, we use the library begin and end functions to pass pointers to the first and one past the last elements in int array. As a result, IVEC will have 6 elements, each of will have the same value as a corresponding int array. Okay. Okay, the specified range can be a subset of the array. Right. The initialization creates a subvec, right, with 3 elements. The values of these are, okay, so we have copies int array of 1 and int array of, okay, less than 4. Okay, so okay. Use library types instead of array. Okay, so use library types instead of arrays. Pointers and arrays are surprisingly error prone. Part of the problem is conceptual. Pointers are used for low level manipulation and it is easy to make bookkeeping mistakes. Other problems arise because of the syntax, particularly the declaration syntax used with pointers. Modern C++ programs should use vectors and iterators instead of built-in arrays and pointers, and use strings rather than C-style strings. Okay. Then we have move on to multidimensional arrays. Strictly speaking, there are no multidimensional arrays in C++. What are commonly referred to as multidimensional arrays are arrays of arrays. Okay. Okay, so I have write a program to initialize vector from an array of int. Write a program to copy a vector of int into an array of int. Okay. So I'll make a new directory 3.5.5. Three 3.5.5. I want to initialize a vector from an array of int and write a program to copy a vector of ints into an array of ints. Okay. So okay, so let me quickly get through this program. Elements of a multidimensional array, range for pointers in multidimensional arrays, and references, type aliases, simplify pointers. Then we have this, and then we are done with the chapter. Then I will move on to expressions. Okay, type conversion operator, precedence table. Okay, great. So let me just get this exercise done. This 3.1. So 3.441 dot CPP. So we will be using std out, std begin, std end, and I won't be using cn and l, and then vector. Okay, so we have int main. So I want to copy. Let me create an array. 1 2 3 4 5 6 7. Then I'm creating a vector of int called ivec, and then I want to initialize it, right? So we to initialize to go begin of ARR and then end of ARR. Then I want to print ivec, and there you go. Ooh, okay, so there is, okay, so it is not defined. Okay, it is not defined for that, so I'll just use a range for, okay, for and ivec. I want to print I. Okay, there we go. So initialize vector from array. Vector from built-in array. Okay. Then I have another program. Write a program to copy a vector of ints into an array of ints. Okay. 3.42.cpp hash include iterator, then hash include iterator, then I have iterator, then I need a vector. Steady out and begin and then we have vector itself. Okay, so I create an vector of int Isaac with values. Okay, yeah, so I'll have 5 values, all initialized to 10. Okay, and then I want const expression. Const expression int const expression unsigned size equals ivec dot size. I think it will give me an error. See the error, yeah. Okay. ivec size is right, call to non-expect function. Right. Okay, so I will go size constant expression, it has to be compile time ready, so I'll simply go int arr 5. Then what can I do is how can I copy this the regular way? No. Size G I less than 5 I plus plus. I simply go arr of I equals ivec of I x and arr. I can simply x. There we go. Okay. So I guess we will call it a day. There you go.